Hey, this is Geometry Chapter 6.6. We're going to talk about trapezoids and kites, which are special types of quadrilaterals. Quadrilaterals would be four-sided closed figures. Anyway, let's see. We're going to talk about how to determine if a quadrilateral is a trapezoid or a kite. We're going to talk about trapezoids. We're going to talk about a special case of isosceles trapezoids, a mid-segment or a median of a trapezoid we're going to talk about. Let's write the word median. They seem to be used interchangeably, and in this case, and let's see, these theorems and properties of a kite. So, definition of a trapezoid. It is a quadrilateral, a closed four-sided figure where two sides are parallel. Okay. So I got all the right notation here saying that BC is parallel to AD. Just in case you forgot, that little arrow symbol means that it's parallel to this line segment over here with the same arrow symbol. If it had two of them, well, then there's two over here. It's a matching pair. These are parallel to each other. These sides here are not parallel. They are referred to as legs. So the bases, the two sides that are parallel to each other are called bases, and these are legs. And well, they have some numeric properties. Since you have a line segment that is parallel to another one and the leg is a transversal, then we're going back to stuff from chapter 3, I believe, where these two interior angles are same side interiors and they have to be supplementary. They add up to 180. And over here to the right, we have a leg that's a transversal cutting across this base and that base. The bases are parallel, so therefore Y and Z have to add up to 180 because they're same side interiors. So there's not just because they're same side interiors, they are same side interior angles where these two line segments are parallel. Then they're going to add up to 180. Now, since the legs are not parallel, then these two same side interiors cannot add up to 180. And likewise the same story up here. Okay. Let's see. Definition of an isosceles trapezoid. Well, if we think back to when we learned about an isosceles triangle, the two legs were congruent. Well, an isosceles trapezoid is a trapezoid. It has two base sides that, the two sides that are parallel to each other, and the legs are congruent, just like an isosceles triangle. So you have a special case where this leg is congruent to that leg, which sets up some, some interesting properties. These two base angles next to this base, they are going to be congruent, and up here base angles next to this base, these two are going to be congruent, which means that, well, and these two are supplementary. Excuse me, I got to fix that. I don't want to see an Apple update in the middle of this. Great, it says not responding. Get away. Go away. Quit. Okay, that's gone. Let's go back to doing math. Okay, these two add up to 180. These two add up to 180, and we have the unique property where this angle is congruent to this angle, and this angle is congruent to that angle. Okay, and I said that here. That is theorem 6-19. If you have an isosceles trapezoid, then in this case, angle A has got to be congruent to angle D, and angle B has got to be congruent to angle C. Okay. If we have an isosceles trapezoid, if you draw diagonals, the interesting property is the diagonals are congruent. Let's go back a little bit and compare that to where we started this lesson. If you look at this, if I draw a diagonal, this diagonal is not congruent to that one. They are not congruent. But go over here to an isosceles trapezoid. Yeah, they are. The other interesting property that they have, which is sort of cool, not covered in this theorem, is that if you mark the point where they meet as point E, you're going to notice that AE is not congruent to CE. This clearly is not the middle. But BE is congruent to CE, and AE is congruent to DE. Okay, let's move on. Trapezoid mid-segment theorem. I've been looking around the internet, and mid-segment is where you're going to find the midpoint of a leg, midpoint, and the midpoint of the other leg, and connect those two midpoints. And it seems to be looking, I was just looking at other textbooks, looking at stuff on the internet, it seemed to be using the word median also. So it seems like those two words are being used interchangeably for this lesson. But anyway, the property is that if you take this base length and this base length over here, add them together and divide by 2, taking the average of them, then you're going to create the length of this median here. So let's see if I got, yeah. So let's throw some numbers in here and get this to happen. So if I just say that this is 10 arbitrarily, and then over here I'm just going to make up the number 16. According to our theorem, let's go back a page. It says that if we take the two bases, add them together, divide by 2, boom, there's your median length. So let's do that. You take 10 plus 16, divide by 2, and you get 13 for a midsegment or a median. I'll just call that a median. It's 13. You're also going to notice that there's a pattern to it. Look, you went up by 3, go up by another 3. So let's just play with that pattern for a moment. Race. Okay, let's make this number 6. Let's make this number 15. We're going to find this length over here. So it's going to be 6 plus 15 over 2 is equal to the midsegment, right? This is going to be 6 plus 15 is 21 over 2. So x is going to be 10.5. Now, students have a little more difficulty when it's the base that's unknown. So let's change this problem up a little bit. So I'm going to make this the x, and let's just pick a couple different numbers. Let's make this, I don't know, 4, and we'll make this 10. Well, following the pattern we've shown before, if this is 4, this is 10, it went up by 6. X is going to be 16, but let's set this up algebraically. It's going to be the bases 4 plus x over 2, the average of the bases, 4 and x, is equal to the length of the midsegment or the median, 10. We'll multiply both sides by 2 to solve, to get rid of this denominator. So you get 4 plus x is equal to 20. Subtract the 4 from each side, and x is going to be 16. It does work. Okay, let's move on. So, we already covered this. Let's see, differences. We could say that 10 plus 18 is going to be 28, and divide that by 2, and you get 14. Going up by the pattern of 4, yep. So if you follow this pattern here, you're going to have the base plus the other base over 2 is equal to 27. Multiply both sides by 2. You get 21 plus x is equal to 54. Tablet's starting to write weird. Oh well, whatever. Let's keep going. Subtract the 21 from both sides, and you're going to get 33. That's cool. Okay. Okay. Next thing, kites. Kites are interesting. They are four-sided, they're quadrilaterals, closed four-sided figure, but the interesting property is they have a pair of consecutive sides that are congruent. So this length is congruent to that length, this one is congruent to that one, but they are not all congruent to each other. Let's throw some numbers there just so this way I'm less confusing. Let's throw an 8 right here. If AB is congruent to AD, they're both 8. And then for fun, let's make this 10 and 10. Okay, so that's the situation of a kite. What I don't like about the phrase kites is that if you go out and fly a kite, there's all kinds of different shapes for kites. But they're focusing on this common shape, and textbooks are calling these kites. Okay, let's work with it. So given this property where these two sides are congruent and those two sides are congruent, what's interesting is that if you connect the diagonals, you create a situation where they intersect at a right angle. And we have to be careful with this because when the diagonals intersect, we're going to find out as we work with these that this particular diagonal here is going to be congruent. But this one, excuse me, I didn't say that right. This particular diagonal is bisected, and this segment is congruent to that segment. But that one's not bisected. That's a problem. We have to be careful about that. We'll go on. Let's see. So we're doing some more math here with stuff just to make sure we understand the lesson. So this is going to be one base plus the other base. Tablet's not writing properly. Divide this by 2. So we are going to get, let's see, 12.6 over 2, so that's 6.3. Let's do some algebra over here. Let's see, it's going to be this base plus that base is equal, over 2 is equal to the median. So you're going to get x plus 10 plus 11 over 2 is equal to 16. Double it. Let's see, and we combine these terms. Let's see, we got x plus 21 is equal to 32. And you subtract the 21 from each side, and we're going to get 11. And let's see, interior angles. Well, these two are supplementary, so let's just give that a letter x. So you're going to get 118 plus x is equal to 180 degrees. And subtract the 118 from both sides, and you're going to get 62 degrees. Yep. And let's see. A little hard to read this one. Let's see, we've got this angle down here, which is 10x plus 15 plus 75 is equal to 180. Why are we doing that? Well, they said it's a trapezoid, and then you see these two are marked as congruent. It's an isosceles trapezoid, which means that these two sides must be the bases. And let's see, so you get what, 10x plus 90 is equal to 180. Subtract the 90 from both sides, so you get 10x is equal to 90. Divide both sides by 10. X is 9. And then MK, let's see on this one. Let's see, this is a trapezoid, and better yet, it's an isosceles trapezoid, which means that this diagonal must be congruent to that one. So MK is the same length as NL. Okay, so this is simple. NL is equal to 4.9. And that's pretty much the lesson. This is a chart that's going to be useful by the end of this chapter, where we're looking at the relationship between all the different quadrilaterals. And that's pretty much the end of the lesson, though. Yeah, thank you for watching it.